All right, chapter 7 is all about normal distribution. So if you notice about the past chapters, chapter 2, we talk about, or was it chapter 2? Was it chapter 2 or chapter 3? You learn about probability, frequency distributions. And then also chapter 6, you learn about discrete probability distributions, and you learn how to construct your probability distributions and also the binomial distribution. So chapter 7 is all about the normal distribution. And we're going to discuss the first 4 sections. So tonight, 7.1 and 7.2. Section 7.1, the standard normal curve. And these are the objectives. Use a probability density curve to describe a population. That's number 1. The second, use a normal curve to describe a normal population. Number 3, find areas under the standard normal curve. And number 4, find z-scores corresponding to areas under the normal curve. And we're going to use all this also for section 7.2 because it's all about the applications of the normal curve. Okay. All right, objective 1. Probability density curve. So the following figure presents a relative frequency histogram for the particulate emissions of a sample of 65 vehicles. So you have RF, you learn how to solve that. That is from 0 to 7 here. So you have the RFs here, and this is the histogram. So if we had the information on the entire population containing millions of vehicles, we could make the rectangles extremely narrow. So the histogram would then look, instead of look at these rectangles here, it's gonna look like this. So the histogram would then look smooth and could be approximated by a curve. And the curve used to describe this probability is what you call the probability density curve. The area under a probability density curve between any two values, let's say A and B, has 2 interpretations. Where's my marker? So let's say this is A and this is B. The area between these two, A and B, it represents the proportion of the population whose values are between A and B. It represents a probability that a randomly selected value from the population will be between A and B. So it's like this, from A to B, the shaded part here is the proportion or the probability between 3 and 4. And you can learn that how to get that probability or area. All right, so if you only have an A, that is just only a line, and the region, if it's a single point, then it has no width, and meaning there is no area, so that's why it's going to be equal to a 0. But from the previous page, if it's between A and B, then you will be able to compute for the area of that. And for the whole curve, the entire curve, the total area is 100% or equal to 1. So we're still talking about probabilities here, and probabilities, you know that your answer should be between 0 and 1. And the total area is going to be equal to 1. So take note again here, all your answers must be, if you talk about the area, must be between 0 and 1. And probability density curves comes in many varieties, depending on the characteristics of the populations they represent. many important statistical procedures can be carried out using only one type of probability density curve, and that is a normal curve. So you learned this before, a normal curve, or you learned different curves like skew to the left, skew to the right, and approximately normal. So, but the whole chapter is all about normal distribution, normal curve. So you're gonna see something like this. And remember also, we learned if it's a normal curve, meaning the mean, the median, and the mode are all the same. That's at the center. So don't forget that. So what are the properties of normal curves? The population mean determines the location of the peak. The population standard deviation measures the spread of the population. So look at this here. Mean is equal to 0 with the standard deviation 1. This is mean equals 0 with the standard deviation 2. The normal curve is wide and flat when the population standard deviation is large, and tall and narrow when the population standard deviation is small. So again, like what I mentioned earlier, the mean, median, and mode they're all equal for normal distribution. Remember this empirical rule. So this is a normal curve, and so far you only know about 68%, 95%, and almost all, and that's exactly 99.7%. So the mean is the center. If you talk about one standard deviation away from the mean, that's why mu minus one standard deviation and mu plus one standard deviation, the total area from here to here is 68%. If you want to get the area from two standard deviations away from the mean, so mu minus two standard deviations and mu plus two standard deviations away from the mean, the center, if you get the total area from here to here, that is equal to 95%. And same thing, if it's three standard deviations away from the mean, that is exactly 99.7%. So you know this from the empirical rule. But for the whole chapter, what if we have in between? What if it's not exactly one standard deviations away from the mean, not exactly two, not exactly three? And that is what we're going to do. And there are different ways how to do that. Finding the areas under the normal curve. There are possibilities like, what if, like the first example, how do we get the area of this? Or how do we get the area of this? Or how do we get the area from here to here? Okay, so objective 3 is finding the area under the normal curve. Or also there are possibilities like, how about this and this? Or also, I'm showing you all different possibilities. How about this? Or last one, how about if you have a normal curve and you are asked to find the area to the left? So I'm gonna teach you how to find all these possibilities, finding the area of a normal curve. So again, there are different ways. First one is by using tables. We're not gonna use that. The second is by using your TI calculator. And that's the easiest and that's the fastest. Okay, so we're talking about the normal curve. Always remember that mu is equal to 0. The center is at 0. The standard normal curve, mu is equal to 0 and the standard deviation is equal to 1. And also that's the default when you use your TI-84 or TI-83. you already have the default of mu equals 0 and standard deviation equals 1. So for this section, you don't need to change your mean and standard deviation. Okay? All right, so z-scores. So we're talking about a normal curve, and this line here, you learned also this from the past chapter, that this is the z-score line. And meaning this is negative side, this is the positive side. Like this is -1, -2, -3, the z-scores, this +1, +2, and +3. So if you remember, z-score formula is x minus the mean over standard deviation. We're going to use that again, especially for the next section. Any questions so far? Okay, we're going to skip all this using tables. You're going to see exactly the same examples, but we're going to use TI-84. All right, so from the previous chapter, when you learn about binomial distribution, remember the shortcuts that you use, binom PDF and binom CDF. Remember that? Here, since we are talking about normal distribution, so we are going to use normal CDF. So since this chapter is all about normal distribution, again, we're going to use normal CDF, and it's the same thing to use normal CDF, that is second vars, and then scroll down, just look for normal CDF. So it's second vars, and then look for normal CDF. So we use that to find the areas under a normal curve. And let's try an example here. Find the area to the left of z equals 1.26. So it's easier to solve this if you sketch a normal curve first. And you know that the center is at 0. So find the area to the left of 1.26. So you have to look for where 1.26 is. So this 1, 2, 3. And let's say let's say this is a 1.26 to the left, so meaning this area here. So we need to find this area to the left of 1.26. So all we have to do second vars, normal CDF. Oh, I'm going to show you using a calculator. Right. Okay, so don't forget it's second vars, and then the second, or press 2, it's going to be your normal CDF. So like what I mentioned, there's a default mean and standard deviation 0, 1. So you don't need to change that for now. All you have to do is change the lower and the upper. So again, just to recall, we need to find the area to the left of z is equal to 1.26. So I'm going to try to sketch again here where 1.26 is. So let's say this is 1.26. We want this area. So from 1.26 to the left, so meaning this is the maximum, this is the highest number, right? So if that is the highest number, that should be your upper 1.26. Okay, so that should be your upper 1.26, and lower is this shaded part here, everything up to the negative side. So you can leave it like that, or sometimes if you don't have that, you can type a very, very small number here. Or let's say you can type, let's say 9999, negative 999, because this is to the left of 1.26, to the left meaning up to the negative side. So that's why lower is up to negative 9999. So paste it, enter, 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 paste, and if you're using TI-83, when you press second vars, normal CDF, open, you're gonna see open parenthesis. You have to type negative 9999 and then comma, your upper 1.26. You can also type just close parenthesis, enter, because meaning it's understood that your mean and standard deviation, mean is 0, standard deviation is 1. Or you can type 0 and comma 1 also. It's the same thing. You will get the same answer. So when you enter this, oh, what happened? Oh, good thing that it showed error, because there's a lot of mistakes when you use a normal CDF, and also when you use this graphing calculator. Again, I'll show you. When you type negative, you have to use this next to the enter. This is the negative, not the minus. I used the minus earlier. I used the keyboard. So you have to use this. This is the minus. So minus 999. Enter, enter, enter. And when you enter this, you will get the answer. Okay, so meaning here, the area, oops, to the left of everything here, the shaded part to the left of 1.26 is equal to 0.8961. I want you to use 4 decimals, or you can say it is 89.61%. Any questions?
Would we round that 1 up?
6.2. I didn't even check the next number. Sorry. Thank you.
I just wanted to make sure there was no particular reason that we didn't.
Yeah. No, you're right. I didn't even check the next number. So 8962. That is correct.
Okay.
Any questions? All right. So using normal CDF, it's best that you identify your lower and your upper, right? So let's go back to our PowerPoint. Wait, I see a chat. Chat. Oh, Michael, good question. Does the negative 9999 ever change? The reason why I use negative 9999, it has to be a very small, very, very small number. You could use negative 9 because that's too far from 0, or negative 99 or negative 999. It's safe to use more nines.
Okay.
So it depends on your standard deviation given. So since this is 7.2, so where's my marker? This 7.1 mean and standard deviation is 1, right? Standard deviation is 1. So meaning
So you just need something less than 1.
what?
So you just need a number less than 1.
Yeah, since to the left, meaning you need, this is 1.26 to the left, so meaning up to the negative side. So this is the negative side, right?
Okay.
So we have here like negative 1, negative 2, negative 3, right?
Yeah.
So here to the left, you're gonna have a very small number here. Since for 7.1, we're using just 1. So think about that. Negative 9 is fine, or negative 4 or negative 5. But for the next section, it's 7.2, the applications of normal curve, you're changing your mean and standard deviations.
Mm-hmm.
You're going to enter your mean and standard deviation. So let's say if your standard deviation is 25, so you cannot use negative 9.
All right.
You can use negative 9. So that's why it's safe. You try negative 9999 or more. Okay.
All right. Also, one more question. Do we ever have it to where it's a plus number, or is it always a negative number?
It depends on the problem. This is only the first example, so you're gonna see a lot. Okay.
All right. Thank you.
Yeah, no problem. So this is only one possibility. This is only one example. So you will see more. All right, like this one. Find the area to the right of negative 0.58. So when you sketch this, where is negative 0.58? So it's somewhere here. This is on the negative side. So think that this is a negative 0.58 to the right of this. So meaning you need the area here. Okay, so meaning this negative 0.58 is your lower, and this is your upper. Do you agree? So when you use a second Vars normal CDF, when you try it now, when you use your calculator, you will see lower and upper. The default here is 0 and 1. So lower, all you have to do is use this. This is negative 0.58. And upper, since this is to the right, everything is going to the positive side. So that's why you're going to use here, let's say 9999. Okay, try that and tell me what is your answer. All right, Anisan William, yeah, 0.7192. It looks correct because, by the way, excuse me, sorry. One of the properties of normal curve you know that the total area is 100%. Since it's 100%, the middle, meaning this is 50% and this is 50%. And by looking at this here, to the right of negative 0.58, look at the shaded part here. You have this, here is 50%. So definitely your answer must be greater than 50%. Okay, so all of you, you got 71.9%. So most likely that is correct. And yes, it's 0.7190. Any questions?
So for our answers, we'll always move the decimal and turn it into a percentage.
No, you don't really have to.
Okay, so either one would be correct.
Yes, yeah, but I prefer the decimals. 4 decimals, okay?
Okay.
Yeah. All right, next one. How about this? This is the easiest among those possibilities because, so find the area between negative 1.45 and 0.42. Where is negative 1.45? So let's say here is negative 1.45. Let's say this is 0.42. And we want to find this area. I said this is the easiest because if it's between two z-scores, meaning these scores here, this from left to right, this is already your lower and this is your upper. You just have to type those. So do that. Second vars normal CDF. This is your lower, negative 1.45, and this is your upper 0.42. What is your answer? .5892. Let's check. Yes, 5.5892. Very good. Any questions so far? This is one of my favorite chapters, chapter 7. Here, you're just going to use a normal CDF and the formula of the z-score. All right, next. Yeah, those are the possibilities. Again, normal CDF. Next is, how about this time, given the area, it's backwards. Given the area, we're going to solve for the z-score. Just like this. The shaded region is 26% or 0.26. We want to solve the z-score here. So what are we going to do? So find the z-score that has an area of 0.26 to its left. But this is by using tables. We're going to use the same. We're going to solve the same problems, but we're going to use your TI-84. Okay. So the next key here is second vars, the third one, inverse norm. That's how you find the z-score. So let's try this. Area to its left is 0.26. So when you sketch that to its left, so meaning it's not possible for you to have a z-score here, because to the left of this line, is more than 50%, right? You need the area 26%. So that's why definitely your z-score should be on this side, so that to the left of it is 26%. So our goal is to find the z-score here. So try this. Second vars, the third one, inverse norm. And when you do this, you will see, I think you should see area. Yeah. You will see area and the default for mean and standard deviation. So area, what area are you going to enter here? So think about this and remember this. The area to enter here is always the area to its left. Okay, so you can only enter the area here, to the area to its left. Since the area is already to its left, which is 0.26, so you enter 0.26 here. Or if you're using TI-83, you will use open parenthesis 0.26 0, 1, enter, and you will get the answer. So try that. What is the answer?
On the tail, do we pick left, center, or right? That's what I got on my calculator.
Oh, you have. Who else has tails? All right. What do you see again? Area.
Area, and then to put 0.26, and then the 0 and the 1, and
Yeah.
then tail, left, center, right.
All right. So actually, if you have this, that's even easier. Because if look at this, the tail. This is the tail, the shaded part. It's on the left side. So you just have to highlight left, and you enter 0.26. Okay.
Thank you.
Yeah. And I will show you the next example. I will tell you why it is easier if you have this left, center, right. Okay, so what's your answer? Oh, most of you, you have negative 0.64. Did you get the same thing, negative 0.64? When you highlight left?
Yes.
Yeah. So negative 0.64. This time, I want you to use 2 decimals. If I'm asking you to find the z-score, just use 2 decimals. Okay, so that is negative 0.64. Any questions? All right. How about this? Area is 0.68 to its right. So if I sketch this 0.68, for you to have a 68% to its right, it should be on this side here, so that this area is 68%, so that this is 0.68. Okay. So here I'm going to show you 2 things. So second vars, inverse norm. Okay, I'm gonna mention first those with left, center, and right. You're gonna see area, so the mean, standard deviation, and tail. So mean 0, default is 1. To its right, so meaning you're gonna highlight right. And you just have to enter whatever is the given 0.68. Okay? For those with a tail, whatever the given area, you just have to enter that and you highlight to its right. If you don't have a tail, this is what you need to, yours is different. If you don't have a tail, remember the area to enter should be the area to its left. So if you want to get this z-score here, we want to enter this area to the left of your z. So meaning, what is this area? So since you know that this is 0.68, so you subtract it from 1. And yes, very good, Luis, that is equal to 0.32. Excuse me. So this is 0.32. So you need to enter here 0.32. Excuse me. Okay. So try that and tell me your answer.
Are we doing this one differently than the previous one?
For what?
The previous example.
Yeah, that one is to its left. This one
Okay,
is
so when it's to the left, we type in what's given, but when it's to the right, we always have to type in what's to the left.
yes, because
Okay.
again, the calculator without the tail, you will see this, right? The area it tells the area that you need to enter here is the area to its left.
Gotcha. Okay, thank you.
So since the given here is the area to its right, meaning you need to enter the area to its left. So you always subtract. You just need to subtract it from 1.
Got it.
Okay. So all of you, looks like you're getting negative 0.47. Did you get those with the tail right? Did you get negative 0.47? And those without the tail, did you get also negative 0.47?
I got negative 0.4676.
Yeah, so that's 2 decimals. So that's,
47.
yeah. Okay. All right, very good. So don't forget that if you don't have the tail, I don't have a tail also. So always think about area to its left. All right, how about this? Middle 95%. Same thing here. It's gonna be easier if you have the tail. But don't worry, I'll teach you without the tail also. Middle 95%. If we sketch this, middle 95%. So think that 95% should be in the middle. So the shaded part is, this is 0.95. And since there are 2 lines here, so meaning you should have 2 answers, 2 z-scores. One is on the negative side, one is on the positive side. Okay? So, again, it's second VAR's inverse norm. So I'll show first those with the tail. This time you have to choose a center. Area, you just have to enter 0.95. mean is 0, standard deviation is 1, tail highlight center, and you will get the answers. Okay, that's for with the tail. Without a tail, so this is 0, 1. Without a tail, remember, you have to think the area to its left. So if you're talking about this Z here, what is this area here? What is this shaded part here?
Be 2.5%.
Yes. So since you know that this is 95%, so 1 minus 0.95 is equal to 5% or 0.5. And since you have two shaded regions here, if you divide this by 2, it's going to be 2.5% or 0.025. So each side is 0.025. 0.025, not 25. Okay? So that's why the area to its left here is 0.025. You have to use 0.025. And then 0, 1, and enter, you will get the answer for this. What is the answer? It's on the negative side, so it should be negative.
Hey, Professor, you said if we have tails to select center, right?
Yes. If you have the tail, select center.
Well, I have two answers then.
Yeah. That's what I mentioned earlier. You should have
Okay.
two, negative and a positive.
So when we answer the question though, like on a test or anything like that, we enter both the negative and the positive number.
Yes, we need two answers here.
Okay.
Okay, so that's why look at the question, find the z-scores. So meaning we need two answers. So
Okay.
again, if you're using tail, automatically you will get the two answers. Okay, so
Well,
here I'm going without a tail. So if you use 0.025, you will see negative 1.96. Do you agree?
yes.
Yes. So that is your answer. And since it's in the middle, you don't need to, for now, for this section, you don't need to enter what's on to the left of this. You could just negative 1.96 is negative, then also it's the same since it's in the middle. So definitely it's the same on the positive side. It's also 1.96. So those are the two answers.
Okay.
And that's what they got for those with a tail. Okay.
Professor,
Or
mine's coming up with an error for some reason.
for what did you?
I typed, okay, so I have the parenthesis, and so I typed in negative 0.025.
It's not negative. It's 0.025.
Oh, okay. That's probably where I went
No
wrong.
negative area. Remember, area is the probabilities between 0 and 1.
Okay, so I just do the positive.
Yeah, it's 0.025. But the
Yeah.
answer is going to be a negative.
Okay,
Okay.
got it.
For those of you, if you ask, how do you get 1.96? If you want, you can change this area instead of 0.025. You add these two. Oops. You add these two because you are getting the area to the left of this z. So 95 and 2.5%, that is 0.975. So if you try 0.975, you will get positive 1.96. Okay. Any questions? No? All right. All right, so that's the end of 7.1. Just to recall, and remember this. So let's say whenever you see this, find the area or find the z-scores. You have to use here normal CDF. Find the area, meaning you have to get normal, you have to use normal CDF. Find the z-scores, you have to use inverse norm. Okay, so don't forget that. And then for 7.2, since it's almost the same as 7.1, it's just the applications of normal curve. We're changing our mean and standard deviation. You will also use this. Find the area, or if you see find the proportion, or find the probability, they're all the same. You have to use normal CDF. Find the scores or z-scores or x, meaning you have to use inverse norm. Okay? Any questions? Take note of that. All right, I'd like to show, before I go to the next one, I'd like to show one more example. Where's a big space? All right. So what if there is a normal curve like this, and I want you to find the areas, find the area of this, so let's say this is on the negative side, so let's say this is negative 1.11, and let's say this is 1.89. So how are we going to find the area of these shaded regions here?
I can't see the numbers. What are they?
Oh, negative 1.11 and 1.89. I just don't have a big space. .89 area, so meaning you need to use normal CDF, right? So how are we going to use normal CDF to find the area of these shaded regions? Selma said the area at 1.89 minus the area at negative 1.11. Nope. So if you use that, if you use this lower and upper, like an example I showed you earlier, meaning you are, if this is your lower and this is your upper, meaning you are finding this area here. Do you agree? But we want these two shaded parts on the two sides. So what do we do?
Do you add those two together?
Yeah, you can do that. Add those two together. How do you get the area here to the left and to the right? You could do that. That's correct. Or also, we're going to use that normal CDF. You can use that Telma if this is your lower and this is your upper. You can use that, but you have to subtract it from 1. Okay, because from negative, if you are using normal CDF from negative, this is your lower, this is your upper, negative 1.11 to 1.89, meaning you are getting this area here, the orange part. But since we want the blue shaded regions, if you subtract it from 1, then you will be able to get those two. So try that. It's area, meaning we need 4 decimals. So yeah, 0.16. 1629, yeah, 0.1629. Okay, any questions? So just in case you see something like this on your homework, you have to you have to subtract it from 1. That's the easiest way. Okay, so I already showed you all the possibilities for solving the areas and finding the z-scores. So let's proceed to the next section, applications of the normal distribution. Objectives: convert values from a normal distribution to z-scores, find the areas under a normal curve, and find the value from the normal distribution corresponding to the given proportion. So take note of this. Find the areas, meaning normal CDF. Find the value corresponding to the given proportion. So meaning this is the area, meaning you have to use inverse norm. All right, so formula for standard normal z-score is x minus the mean over standard deviation. Just like an example here, consider a woman whose height is 67 inches from a normal population with a mean of 64 and a standard deviation of 3. Then you will be able to compute for the z-score. Substitute those values. 67 minus 64 over 3 is equal to 1. So by looking at this, the mean is 67 and, mean, not this one, mean is 64. And remember, in a normal curve, the center is the mean. So that's why you have the center here is 64, and you want to get when it is 67. It's the same thing as the center is 0 for the z-score, and that is equivalent to z-score of 1. 67 and 1. So again, finding the areas, it's exactly the same thing. Normal CDF. Who wants to read example number 1? Volunteer, read example 1.
I will. Example 1, area under a normal curve. A study reported that the length of pregnancy from conception to birth is approximately normally distributed with mean 272 days and standard deviation 9 days. What proportion of pregnancies last longer than 280 days?
All right, thank you. So as you can see here, what proportion, I mentioned if you are asked to find the area, the probability, or the proportion, so you have to use normal CDF. That's always the hint. No matter what, you have to use normal CDF. And then you have the mean and standard deviations here. So mean is 272 and standard deviation is 9 days, and your X is 280. So I'm not going to ask you to use the formula X minus the mean over standard deviation, because you can just use a normal CDF. But first I want to show with the normal curve. So since the mean is 272, that is the center, 272. You want longer than 280 days. So let's say this is my 280. Longer than 280 meaning to its right. The right of 280. You agree? So when you use normal CDF, you will see lower, upper, mean, and standard deviation. So you will see lower, try it, second bar is normal CDF. You should see lower, upper, mean, and standard deviation. So for the area to its right, remember, 280 is it lower or upper? What is 280?
Upper.
Upper? That is lower. Because longer than 280 days, meaning to its right. So meaning from 280 to the right is up to the positive side. So that's why this should be the lowest. So that is your lower 280, and your upper here is going to be a very big number. So that's why we try 9999. Okay, and mean, don't forget to enter. This time you have to change the mean and the standard deviation. Mean is 272 and standard deviation of 9. So enter this and you will get the answer. What is your answer?
I got negative 0.3129.
Negative.
I got 0.1870.
What did I do wrong? Hold on, let me do it again. I messed up. I put my upper at 272. I messed up. I'm tired.
Wait, let me see. Let me double check. Second verse, normal CDF. Uh, $280, 272. What did you get? Oh, sorry, I didn't see it. Yes, Louise has an answer. So,
I got 0.18. 70.
yes, that
Okay.
is correct.
No, I had for the upper. I had entered 272. I did it wrong.
Oh, okay, yeah. All right, did you all get the same answer? You should get 0.1870. Okay, very good. Next example, who wants to read example number 2? Volunteer?
I'll do it. The length of a pregnancy from conception to birth is approximately normally distributed with a mean of 272 days and standard deviation of 9 days. A pregnancy is considered full term if it lasts between 252 days and 298 days. What proportion of pregnancies are full term?
All right, thank you. So here, as you can see, proportion again, so that is, you have to use normal CDF, and the condition here between 252 and 298. So remember, if you have between two numbers, meaning that's already your lower and upper. So this is going to be your lower, and this is your upper. That's the easiest if you are solving between two numbers. And then you have the given mean and standard deviation here, then you will be able to get the answer. So try that. Second was a normal CDF. So this time it should be 252, 298. Mean is 272 and standard deviation of 9.
I got 0.9849.
Did you all get the same answer? Say that again, 0.9849.
Yeah, 0.9849.
All right, thank you. So Cami said the same thing. Check. Yes, it is 0.9849. All right. Next is this time backwards again. Find the value. So meaning we need to use inverse norm. This is by using tables. So let's skip this and use inverse norm. I need another volunteer to read the problem. Anyone?
I'll do it. Oh,
Go ahead.
all right. Mensa is an organization whose membership is limited to the people whose IQ is in the top 2% of the population. Assume that scores on an IQ test are normally distributed with a mean of 100 and standard deviation of 15, what is the minimum score needed to qualify for a membership in Mensa?
Thank you. Score. So that's why you're going to use inverse norm. But remember, when you use inverse norm, you're going to see area, mean, and standard deviation. So there's always given mean and standard deviation. So you just have to type mean 100, standard deviation is 15. But the problem is, what is the area? So you have to understand the problem here. Top 2% of the population, if you have a normal curve, sorry, this is not a good normal curve. So top 2%, where is top 2%? From negative to positive. So do you agree that this is the top 2%? Mean is 100, so that is the center. Now we want the mean score is 100. We want to get the score here. What is the score here? To qualify for membership in Mensa. What is that minimum score? Okay, so if you're using, if you have a tail, what do you need to do? I'll ask first for those who has a tail. What are you going to do if you have a tail? Again, for those who has a calculator with a tail, what are you going to do here?
To the right side.
Yes, very good. Your tail should be to the right. So you have to highlight to the right, and then you just have to enter 0.02. Okay? And you will get the answer. If you don't have tail, what is your area?
Would it be 0.02?
If you don't have a tail, what do you need to, what's going to be your area?
0.98.
0.98. Remember, you only enter, if you don't have a tail, you enter the number, the area that is to the left of your value, of your score. To the left of this score is, meaning this is 98%. If this is 98%, this is 2%, right? So that's why you have to enter here 0.98. Okay, so now what is the answer? So yeah, so 130.81. Anahi, how did you get that answer?
You know what? I got the same thing as you guys, but on my calculator it's showing like E2 at the end. And you know how before if it was negative E something, we had to move the decimal to convert it.
Uh-huh.
So on this one it's not like E minus 2, and I thought it was, so I moved the decimal.
So what's on your screen?
So it says 1.38 30806 blah blah blah, and then it's E2. And you know how before when you said if it was like E negative 2 at the end, we had to move the like decimal over 2 times. So that's what I did, but I didn't notice it was positive.
Yeah, if it's
Yeah.
positive, you move it to the right. If it's negative, you move it to the left.
Yeah, I didn't notice it wasn't a negative, my bad.
Okay. All right, any questions? So again, if you don't have a tail, don't forget, make sure to enter the area that is to the left. All right, so that is actually the whole 7.2. And I'd like to solve some problems from the book. So if you check your Connect Math, I assigned chapter 7, and you will see 35 problems. You should be able to work on 7.1 and 7.2 this weekend or tonight, starting tonight, the first 20 problems. Okay, so again, the first 20 problems, that is for 7.1 and 7.2. So that's a good practice of your normal CDF and inverse norm. So please do that, try that instead of, even though chapter 7 is due next week Sunday, because we still have to discuss 7.3 and 7.4 Monday, but please work on 7.1, 7.2, because your next quiz is on Wednesday next week about chapter 7. Okay. Which problems? Wow. We're always working with the concepts, and let's try 27. Oh, Jared, I mentioned it earlier. I said I'm not done yet. So it's a long test, so maybe by tomorrow. Although I already graded half of the class, so sorry about the other half. Okay. All right, so 27, check your blood pressure. In a recent study, the Centers for Disease Control and Prevention reported that the systolic blood pressures of adult women in the United States are approximately normally distributed with a mean and standard deviation given, mean 80.5, standard deviation 9.9. Letter A. Look at the question. What proportion of women have blood pressures lower than 70? So proportion, that's the hint that you need to use normal CDF. Lower than 70, if you see lower, what is 70? Is this upper or lower? Upper, very good. So that's going to be normal CDF of, let's say, negative 999970. Then you have to enter your mean and standard deviation, 80.5 and 9.9. So try that. And answer, that's correct. Thank you, Amanda. 0.1444. Letter B, what proportion, again, so that is normal CDF, and of women have blood pressures between 75 and 90. So between, meaning that's already your lower and upper. Lower is 75, upper is 90. And using the same mean, 80.5, and standard deviation, 9.9. And Anissa has an answer, and that is also correct. 0.5421. Very good. C, the systolic blood pressure greater than 90 is classified as hypertension. What proportion? So proportion, again, normal CDF. Greater than 90. So 90 is what is 90? Is it lower or upper? It's lower, yes. So 90. So definitely your upper. Let's say use 999 and 80.5, 9.9. Answer. .1686, yeah. Very good. Then letter D, is it unusual for a woman to have a blood pressure lower than 65? Lower than 65, just like what we did for letter A. Lower meaning 65, meaning that is your upper. So you change this to 65. And what is your answer? So William said 0.0587. Very good. Now the question, is it unusual? When is it unusual again?
Less than 0.05.
Less than 0.05. So this is greater than 0.05, so it's not unusual. Yes? Questions? Any questions? Are you sure? Easy? All right, one more problem, and I want to show a number, the last one, 49. Precision manufacturing. A process manufactures ball bearings with diameters that are normally distributed with a mean of 25.1 millimeters and a standard deviation of 0.08. Find the 60th percentile. Where's my... So remember percentile, you learned this from chapter 3. So meaning 60th, meaning that is 60%. So you have the standard deviation and the mean given the area. What do we need to use here? Inverse norm. So meaning the area to its left, that's already the area to its left is 0.60. Then 25.1, which is the mean, and the standard deviation of 0.08. Okay, and you will be able to get the answer. So whenever you see a percentile, that is the area to its left. What is the answer? All right, there's a question here, why? All right, what example, which example are you talking about? The one on 7.1. But you said the examples we have right now, which examples are? Like before we move to 7.2, which? All right, again, the example earlier with this two, whenever you see this type of problem, you're gonna need to use 1 minus normal CDF. This, whatever you have here, this is lower and this is upper. That's the reason why you are subtracting it from 1, because if you don't have this, if you only use normal CDF of lower and upper, this is this part. This orange part is this. But you want the shaded part on this side and this side. You want this area here and you want this area here. So that's why if you subtract this orange region from 1, you will get these two sides. So which problem are you? The examples are letter A about systolic. Right. Sorry, there's a question here. All right, so this is the systolic, what was the, yeah, systolic blood pressure. Which one are you? Lower than 70, if you, lower than 70. So 70, lower than, this is the shaded part. Between 75 and 90, that's 75 and 90. So this is this part. Greater than 90, let's say if this is your 90, so greater than is this shaded part. Letter D, lower than is like letter A. But this one that I showed you, when it's you subtract it from 1, when you have these 2 shaded regions here on the sides. Okay, that's the only problem that you will encounter. You subtract it from 1 when you see this. Okay, so any other questions? Don't be shy, because you're gonna answer 20 problems, homework problems, and you might encounter this type of problems, right? This is number 49. So what is your answer here? Inverse norm 60%, meaning that's a 68th percentile of 25.1 mean, and standard deviation 0.08. What's the answer here? $25.12. Okay, that is correct. The next, letter B, find the 32nd percentile. So that's 32nd. So again, this is inverse norm. So that is 0.32, that's 32%. So with the same mean and standard deviation. So try it again. Yes, that is correct. 25.07. Then letter C, this hole has to be designed so that 1% of the ball bearings will fit through it. So 1%, what should the diameter of the hole be? Yes, that is also correct. So it's like you just have to change it to 1%. That is 24.91. Okay, and last one, between, not between, middle 50%. Do you remember what to do if it's a middle? If we talk about middle, so if you sketch this, so meaning the center is 50%. So this is 50%. So what are the 2 scores here? What are those 2 diameters? So if you have the tail all you have to do is inverse norm, 0.5 center, and you will get those. Oh no, maybe not. Sorry, this is the one that I'm glad I showed this. For those who has a tail, if you try 0.5 and then center with the mean and standard deviation, what are you should have two answers, and what are those answers? So this is for those with a tail. So 0.5, mean 25.1 and 0.08, and tail is center 25. You got 25 point. Oh, yeah. All right. If you got those two answers, then you don't have to worry. Everything is correct. Okay. So if it's not, if you don't have a tail, what do we do here? So meaning the area to its left, to the left of this, what is this area? What is this area? If this is 50%, the other two sides should be 1 minus 50.
25% each.
Yes. So this is 50%, and when you divide it by 2, should be 25% each. Very good. So here you have to be careful. So you have to find the area of the first one. To its left is 0.25. Okay? What did you get here? You should get 25.05. Okay? The other one, unlike what we did earlier, that if it's negative, you just have to enter the other one's positive. No, if it's applications like this, you have to solve the other side. Whereas this side here, to the left, the area is 0.75. Or you can just add this, 0.25 and 0.5, that's 0.75. With the same mean and standard deviation, and you should get an answer here, 25.15. Okay, so you have to do it twice. You have to change the area 0.25, the other one 0.75. If you have a tail, you just have to enter 0.5 center, you will get these answers. If you don't have a tail, you have to do this. Okay? Please
So
don't.
when we write that answer, do we just write both answers?
Yes, there will be two answers. Because
Gotcha.
it says between what two values, meaning we need two answers.
Oh, okay, that makes sense. Thank you.
Okay? Any questions? All right.